Okay, welcome to APNIC eLearning webclass, and this session is about the introduction of MPLS. So we will talk about some history, some advantages of MPLS, and then we will talk about some principal parts of MPLS, the label, and how to forward a package by using labels. Okay, so before we go to agenda page, first I would like to introduce myself. My name is Jessica. I am a training officer in APNIC. And here is my email. And for this session, if you have any questions, please type in the chat, and I will try to answer the questions as soon as possible. And after this session, I will share our slides and the survey link with you. So I will share the FTP link for you to download the materials for this session. Okay, so for this session, this is the agenda page. You can't see which part you can't. Can you see the slides? The camera is not working properly, because the camera is not the one I want to connect. The other, only the one, by built-in one can be connected. Yeah. Sorry, my connection was off just 1 minute ago. Okay. Yeah, hope you can see the slides. Now we will continue the session. I think today there is some issue with the connection from our user end to the server, Adobe Connect server. And so for this session, we will talk about the definition of MPLS, what is MPLS, and the advantages of MPLS, some features or advantages. And then we will talk about the applications. So where can we use MPLS? Mainly MPLS are used in what type of services. And after that, then we will talk about some architecture of MPLS, and then the label. We know the labels are important in MPLS. The format of label, and how to use the label, and then how to set up the LSP, the basic principle of the LSP setup, and also how to forward the package by using labels. So these are the main contents, the basic introduction for MPLS. We will not introduce any other protocols related to MPLS. For example, we will not introduce LDP or MPBGP or MPLS TE for the RSVP. No, we will not introduce those protocols here. Yeah, so you can see the slides. And then for the definition of MPLS, multi-protocol label switching. Multi-protocol label switching, you see this is the name for this MPLS. We call this MPLS is like a technique. And for the multi-protocol here, that means support any network layer protocol. So MPLS is working between the data link layer and the network layer. And some people call the MPLS as the 2.5 layer, working on the layer 2.5. So if you say the layer 2 is the data link layer, and layer 3 is the network layer, and MPLS, we will say this is working between the 2 and 3. Some people say the layer 2.5. is like this. So then sorry, my connection has been disconnected again. I don't know what happened to Adobe Connector today. If this will happen again, I will change to another laptop. Okay. Yeah, just because my connection was off. Okay. So for the multi-protocol, you can see he supports the any layer, the network layer for this one. So inside the MPLS packet, and can be you can say IPv4, IPv6, IPX, and CLMP. So different network layer protocols can be supported. And so some people for example IPv6, and we can carry for example inside is IPv6 packet, and then similar the labels will be added. And so for the label, multi-protocol means the network layer protocol, multiple can be supported. And the label, short label will be used to encapsulate packets. This label will be used. And for the forwarding, packets are forwarded by label switching instead of by IP switching. So we will check the label information and then forward the packets, and not based on the IP routing table to forward the packets, based on the label forwarding table. So label will be used, and label forwarding table. And the initial motivation of MPLS. So MPLS initially was designed for some issue. You see what is the requirement here. You see, for the initial motivation, because for IP forwarding, and then we see, oh, IP packets, and for IP packet arrive one router, how can the router do the forwarding? We are using based on the IP routing table. If your destination is 128.89.25.4, and then we will use this destination IP address to logical and the mask, network mask, the /16, and then get the prefix, get the result whether they match the prefix or not. And then we can find multiple, maybe multiple routes can be used to forward this packet. And if multiple answers, then we need to find the longest matching, and whose network mask is the longest one, and then we will choose that one. This is for the IP forwarding, IP lookup. And so people consider this IP address lookup was more complex and take longer time. That is what during that time for IP forwarding consider will take longer time. So people are considering, oh, maybe the label swapping protocol can be faster. So the label, they don't need to mask any of the network mask subnet, and then just check the label and exact matched, then forward the information. So the operation would be faster than the IP address lookup. So that based on this request, and MPLS was initially invented to make the forwarding path faster. And I hope you can get to the point. Using the label, you see this exact number match and then forward. We don't need to match the network prefix, the mask, and then forward the packets. Consider this, the IP forward address lookup was slower. And so MPLS developed, but in fact MPLS can be used. So you can see here MPLS developer, you see, for the we don't need to check for the IP address, and we just for the MPLS domain, and then they just need to check, oh, the label is 20, and then we will change the label to be 30, and it sends out from the interface Ethernet 0. And then if the incoming label is 30, and then we pop out the label and then forward the information. So just check the label and forward the information. No need for the IP lookup. That is fast and simple. And so that is the initial requirement for MPLS. But after a while, you can imagine nowadays, especially after several years, and the hardware of the routers has been improved a lot. And so the advantage of MPLS was rapid forwarding. But after our hardware has been improved a lot, and the difference of the forwarding speed, we can't see that. We can't see the big differences between them. MPLS forwarding is faster than IP forwarding. You cannot feel that difference. So that MPLS, the rapid forwarding, is not the advantage of MPLS anymore. And so what will be the reason why MPLS is still used? So the important reason is the MPLS decouples forwarding from routing. So the forwarding paths will not be decided by the routing and support the multiple service models. There are some other reasons for MPLS to be used. So the initial reason, MPLS designed for the faster forwarding, or label forwarding is faster than the IP forwarding, and but because of the hardware has been improved a lot, so that is not the main reason. The main reason is MPLS can be used for different services. And here you can see one application for MPLS is VPN, Virtual Private Network. You see, Virtual Private Network. And we have the VPN, and then we are sharing the same public network, and then different branches of one company, they are connecting to the different border routers of service provider, and they feel like they are under the same, they are connecting to each other directly. And so this is the virtual private network. They feel like they are connecting to their own private network. And for the MPLS technology, because he has the nesting labels, so label can be nested and multiple layers of labels, and then so one layer of the label is for the VPN, and the out label is for the tunnel label, and can be shared in this public network. And so we can separate. So in this public paths, they are forwarding the packets, whether received from the VPN B or VPN A, they just forward to the right PE routers, and then they can reach the destination, and they don't need to be, so different VPN, they will not mixed with the other VPN paths, and they will go to the right destination. So this is the MPLS VPN technology has been used very widely, and he can support both layer 2 and layer 3. And for layer 3 VPN, we are using BGP for the VPN label, signaling BGP. And for layer 2, they can use LDP or BGP. And so they have Compiler and Martini, different modes, different techniques can be used. So these are for the MPLS VPN, which used very widely, and many products can support this very well. So this is one important feature. And VPN can be supported because we have the nested labels can be used in the forwarding paths, and the protocols all can be used extended to support this feature. And so this is one important. Normally, I consider this is the most important feature or service for MPLS. And adding to this VPN, there is another one, is the traffic engineering. So MPLS traffic engineering has his own advantage compared with the IP traffic engineering. So traffic engineering, that means for different traffic, how can we guide them to different links? Traffic engineering. And for IP, what can we do? IP, normally we are using the shortest paths based on the cost. For example, OSPF is based on the cost, and then go to the shortest link. And if you have multiple, you want to share the traffic on the multiple links, and maybe you use the equal cost load balancing and ECMP, equal cost multi-pass. And from router, for example, here from router 1 to router 6, and maybe you want to use only one link, for example, the GE link, and to forward all the traffic. But then a FE link will be fast Ethernet will be empty. So we didn't really make use of this fast Ethernet. And from the GE link, how can we realize the load sharing between them? But if you use IPTE, and that will go to 50-50. And this is not what we want, because the GE, of course, can carry more traffic. So for MPLS TE, what can we do? And we want to for the GE link to carry maybe more traffic, and the FE link carry less traffic. And so how can we make it? From the MPLS TE, he can create a tunnel from R1 to R6, and the path can be decided from the R1, R2, R3, R6, and then from R1, R2, R4, R5, R6. This is the other link. So we have the two tunnels will be created, and the bandwidth will be reserved for each tunnel. And then you can guide the traffic into the separate tunnel. And then for example, you can guide, maybe for the media, for the video, and then we will guide into tunnel 1. And this will take more bandwidth, go to this one. And for the voice, and it will take less bandwidth, and then we can take the lower link. So you guide the traffic into the tunnels. So this is the MPLS TE. You can define the path. You can define the path, or they can calculate the path based on also can calculate the path automatically based on the bandwidth. So this is also another feature of MPLS, another application used by MPLS, except the VPN. And another one, quality of service. We know nowadays the quality of service is definitely an important part in our network, in the service network. And for different services, and we want to provide a different guaranteed paths. And so MPLS, he doesn't define a new QoS architecture. He can support quality of service, and using a similar information as the IP diff serve. So for the IP diff serve, we have the DSCP, and then what can we happen? You see, if this is from the one IP domain, and they are all supporting only IP paths, different traffic come in, and then we suppose, here for the IP packets, and then we have the DSCP to mark the color, different color, and then different, maybe some are more important, some are less important, then you can mark the packets and differentiate all the traffic. And so this is DSCP. DSCP will take 6 bits and to use and to represent the information. And then when the traffic come into MPLS domain, how can we still treat them differently? And based on the traffic class, and for MPLS, he can also support. MPLS has the 3 bits to support the traffic class. Before we call the name is EXP. I think nowadays many routers, they still call this part is EXP. Even later, we show one example, the trace router, the EXP on Cisco routers, he still put that is EXP, experimental, for that's 3 bits. And now, in fact, we call this is the traffic class, TC. So for this part, if the packets are carried like this, so before was the IP packets, and then we will carry the MPLS label. And in the MPLS label, we can use the 3 bits. to carry the information. So similar, you can map the DSCP to the traffic class. And if you are running VLAN, so you can also map the Q tag and then into the traffic class. So the MPLS can also support the quality of service. So these are the main three applications of MPLS used nowadays in the service provider network. So you can see these are the reasons why MPLS are used widely nowadays in our network. And so normally we can compare, to better understanding MPLS, we can compare the different similar technologies, not similar technology, just for the data forwarding paths. We have IP and native Ethernet and MPLS. In fact, I think based on this table, you can easily understand MPLS, because sometimes people, especially the new learners, they will be confused. They say, oh, now I'm learning the telecommunication, I'm learning OSPF, I'm learning MPLS, I'm learning BGP, I'm learning LDP and IP. So will be confused with what are they can only remember, oh, these are different abbreviation words, and then they may be confused. Oh, what is the difference between OSPF and MPLS? Are they similar things? And so here from this table can help you understand the position better. So IP, you can see IP will based on the destination IP address to forward the information. And the control plane for IP, what are the control plane? You can see the routing protocols. So before I mentioned some protocols, you should put the protocols here, OSPF and ISIS and BGP. So for the control planes, I just list some dynamic routing protocols, and of course static route is also the control plane, and I listed here, so you know the position is here. And for the native Ethernet, and we have the using based on the MAC address, and from the route for switches, when they forward the information based on the MAC address, the MAC address table. And so here is based on the MAC address. And for the continue, then for MPLS is based on label for the forwarding, and then forward the information based on label. The table is the label forwarding table, and oh yeah, he supported TTL, and IP also can support TTL, one hop and reduce one value. And for the MPLS, the control plane can be set up by the routing protocols or label distribution protocols. So the labels will be distributed by the label distribution protocols. And we have the LDP is the one protocol to distribute labels, and MPBGP. And okay, here, in fact, if we don't want to confuse people, you can also call BGP. Yeah, BGP can allocate labels, and also RSVP-TE. So these can allocate labels for the communication. And so these are for the normal for the allocating the labels we can see. And for the packet encapsulation, and we have the IP header, so one IP header and the other IP header, and then here is for the layer 2 header, and for MPLS header we have the label. Later we will talk about that one. And quality of service, we have the 8-bit type of service in IP header. If you are using DSCP, and DSCP is using the 6 bits inside the TOS. And the VLAN tag. In VLAN tag, we have the 3-bit priority, and also for the traffic class in the label, 3-bit traffic class in the label. So and also the OAM for the pin and trace route. Later we can see when you do the troubleshooting, we'll use the pin and the trace route for MPLS. So this is the So John cannot hear the audio. The video is not playing, the camera is not working, and but the audio should be on. Okay. So here for this table will be useful for you to understand the MPLS. So you can understand MPLS as a whole technology, and inside this technology there are different protocols connected related to this one. And then continue for the evolution of MPLS. You see MPLS is how to say it is younger than IPv6. And the formulation for the IETM group is 1997, and for that technology, MPLS, the technology was you see initially in 1996, different companies, different technical companies, they have announced their label switching plans. You see different companies, they have contributed for this technology. And especially for example Cisco, they have the tag. They call the label as a tag. I think in some parts you can also see some tag and information even in the products. And so since then, and then MPLS has been developed, and the first RFC released in 2001 about MPLS. And so that you can see but for the production parts, MPLS layer 3 VPN deployed, and then large scale of layer 3 VPN in 2004, 2005, and 2006. I think after 2006 or 2007, also large scale MPLS layer 3 VPN network deployed in the world. Yeah, and so this is you can see the layer 3 VPN large scale and layer 2 VPN, and then the large scale multicast and the transport. And now is for the optimizing for the cloud and transport. So in fact, for the layer 2, layer 3 VPN traffic engineering, these technologies are already quite mature, used for many large networks. So that's why many products can support these features very well. And for the total application scenario, I use this simple topology to show to integrate the technologies here. Many other services. So you see we have the layer 2, layer 3 VPN. So layer 2 VPN, as I said in today's first session was the layer 3 VPN. So here for layer 2 and layer 3 VPN, MPLS layer 3 VPN, the PE, we see the PE, these are the edge routers on the provider network. So you can imagine this in the middle, these are the provider route network. And then we have different customers connecting to the public network, the MPLS domain. So layer 3 VPN, we just mentioned a little bit of the difference between layer 3 VPN and layer 2 VPN. So layer 3 VPN, the PE will carry the routing information. He will carry all the routing information. The VPN routing information. And for layer 2 VPN, the public network is acting like a one layer 2 link. So for the routing information or something, all these are carried in the layer 2 parts. So the PE routers, they will not maintain. Okay, maybe using the maintain, that word is more correct. Maintain the PE will maintain the VPN routing tables. So the PE routers, they are maintaining the VPN routing tables. But for layer 2 VPN, the PE routers, they will not maintain this information. They just provide a layer 2 link. So the public network, the PE routers, PE or P routers only provide the layer 2 link. Provide as the layer 2 link, provide the connection. As you are like provide a one layer 2 link, or maybe a switch, or maybe a point-to-point link to the other side. So this is for the layer 3 and the layer 2 VPN we can provide. And then after we are running the VPN services, for the customers, we can separate between each other, and then we are running MPLS in our topology, and we can use labels for forwarding. And so for the traffic engineering, and because for some path, we want to fix the path from the maybe customer 1 to customer to his branch, and then we want him to only choose the path from PE1P and between P and to PE3. So we want to fix the path, and then you can use the TE to fix the path. And using MPLS TE, one part is can do the using different paths to guide the traffic, and the other very important feature is the backup. So the fast reroute, or maybe the for the redundant path. So when the main path is done, and then we can use the other path immediately. So this is another important feature of the MPLS traffic engineering, that is the redundancy. And so when one path is done, and we can use the other one immediately. So this is also used for MPLS TE. And so this is another feature, and also for the quality of service. So because the quality service, they are still using a differentiated model for the quality of service. So when the traffic come in, and then the border router, PE routers, they can do the traffic shaping or marking, to mark to the remarking from the DSCP mapping the information to our TC traffic class. And then inside the MPLS network, based on the traffic class, the value, and then we can treat them different based on the congestion management, congestion avoidance. And when the traffic leave our network, and then we can do the policing traffic shaping. So this is the same differentiated QoS model. So this is how we combined all the different services into the one simple network as an example. If you have any questions, you can type in the chat. Yeah, this part is more like the introduction. And then for the MPLS architecture, and if we consider this is inside one router, we have the control plane and the data plane, the forwarding plane. So control plane, and then we will generate an IP routing table, and based on IP routing table, and he will collect the different information and generate the routing table, the RIB information, and then generate the forwarding information base. And for the label parts, we have the different label distribution protocols. They would exchange the information with other routers. So we will have the routing protocols. You have OSPF neighbors. They are talking to each other, exchange the information. And label distribution protocols, for example, LDP, they will talk to the neighbors and to exchange the information. So these are the protocols to talk to different neighbors to exchange the information. And then we can have the routing table. And for the label distribution protocols, they can, based on the routing table, and then generate the label forwarding information base. So we have the routing forwarding information base, and for the FIB and then label LFIB. So there are two questions. Can we consider MPLS layer 2 and layer 3 VPN as an alternate of IPsec VPN? Yeah, so yeah, some network they don't use MPLS, then they are using IPsec VPN. And yeah, if you are using MPLS layer 2, layer 3 VPN, and then but in our previous session, one participant said for the enterprise they are using IPsec, and but they can still use the MPLS VPN in the provider part. Am I clear? I'm not sure whether I have answered your question or not. So in some networks, they only run the IP. They will use the IPsec VPN. And for the MPLS layer 2, layer 3 VPN, and then if you are already running IPsec, but the service provider can still give you the MPLS VPN options. And okay, so for this question, okay, so here, okay, so here for the, you want to see if you are not using, okay, that is for the second question. On Cisco routers, you need to enable Ceph. So on Cisco routers, before you enable MPLS, you need to enable Ceph. And for Megan, and here, you want to see if you are not running IPsec VPN, then you are using MPLS layer 2 or layer 3 VPN. And here is like this. And some networks, if they don't run MPLS, they are only running IP. And for the VPN requirements, they are running IPsec VPN. Yeah, this is, you can select one maybe IPsec VPN, or you can also, if you want to deploy MPLS, and then you can use MPLS VPN. And another example I am giving here is the case, for example, for your enterprise, you are running IPsec VPN from your customer edge router to the other customer edge router, CE to CE, you are running IPsec. And but for the public parts, the service provider, they are also providing MPLS, so you can run both of them. Am I clear? Am I clear, Jen? Okay, then I will continue. So for the, okay, I just want to add one thing. If you want to compare IPsec and MPLS, how to say, for security part, IPsec is more secure. IPsec can provide the encryption and authentication parts, but MPLS cannot provide the encryption or authentication part. And the advantage for MPLS is he can provide the layer 2, layer 3 more flexible, and also the peering path is easier compared with IPsec, because IPsec is point-to-point peering, and for MPLS layer 3 VPN it is not the point-to-point in that case. So you only be full BGP peering connected, and then you can add the VPN. So it's more flexible and compared with IPsec VPN based on the peering path. Am I clear now? Okay, then I will continue. So for the MPLS architecture, you see the control plane, and we have the IP routing paths, and also the label paths. Label, we have the label distribution protocol and protocols, and then label information base. And so what can we get? You will get the forwarding information base and the label forwarding information base, and you will check these two. And here I want to emphasize one thing. You see, These two parts, the two colors, the green color and the orange color, they are not totally separated. They are still connecting with each other because our label distribution protocols, when they generate the label forwarding information base, they will use the routing information base. So routing information base is still important. And here solved one problem. Here the routing information base, it is the basic part. So in many networks, some people are asking, oh, MPLS can provide the forwarding, so why do we still need the OSPF? You already run MPLS and MPLS can use a label for forwarding. Why do you still need OSPF? Because OSPF can generate the routing information base, RIB, and the LDP, when they generate a path, allocating the labels, the path is based on the OSPF. This is an example. So the routing information base will be useful for our label distribution protocol. Okay, and come back to our chat. You mean MPLS doesn't ensure encryption of data? MPLS will not encrypt your encryption. So the IPsec, the ESP or ESP will provide the encryption, encrypt the packets. Later, when I explaining the label for the MPLS header, you will see he doesn't provide any encryption here. So IPsec is the protocol header, ESP or provide the authentication or encryption. Yeah, so that's true. The MPLS by itself, he will not provide the encryption. Okay. Yeah, so here for the forwarding part, and we can have a look. So if one coming packet is the IP packet, that is a normal IP packet with the IP header. And then for the forwarding information base, he will check because there is no label. What can you check? You will check the IP routing table. Oh, what is the destination IP address? And then check based on this one. And based on this one, if there is any forwarding is going to allocate a label or something, then maybe we'll allocate a label and then forward the information. But if the incoming is a labeled packet, and then we will check the label. What is this label? And then based on label to do the forwarding. And so please remember, you need to check the routing information part and also the label forwarding information base. These are the two forwarding planes parts. And then for MPLS Topology and some names of the router, and we will have all the routers who already enabled MPLS, and then or support MPLS. We call them the LSR, label switch router. And for the LER, the label edge router, so the border one, the connecting with IP paths. So here supporting MPLS, and the other interface is supporting IP, so LER. And LSP is the label switched path. And when we are talking about any technology about MPLS, we will always mention about the LSP, label switched path. So the label switched path, some people, some new learners, they will consider, oh, we want to find a path or something. In fact, that is not a real path, it's the labels. So on each router, you will check the labels, incoming label, outgoing label, and then check his incoming, outgoing. So we match the labels, and one by one, then we can form one path. So this is the LSP, and later we will see that one. And in the MPLS domain, and if we are using the label for forwarding and for the packets, we will add the labels. So this is one topology, and then come to our label. We talked about a label before, and so what is the label here? In your packet, so before your original packet is one layer 3 packet, IP packet, if this is an IP packet inside for example, layer 3 VPN, and then add a data link layer header, destination MAC address, source MAC address, and then this is original packets. And if you get into the MPLS domain, and we will use the label for forwarding, and then we will, so maybe the router will insert or add one label or two labels or three labels or four labels into the packets. So here we have the label. One label, the length is 32-bit. And so the exact label value will be 20 bits. Okay, so the label value exact is 20 bits. Not the whole 32 bits are for label. No, only the 20 bits here. And then we said for MPLS we have TTL, time to leave, 8 bits. The function is same as the IP part. And TC is the traffic class. And some parts still called the EXP. So that 3 bits will be used for the quality of service, 3 bits. And then there is one S bit, is bottom of stack. Bottom of stack. We will see it here. So label stacking. As I said, the labels, you can add multiple layers of the labels. So how come? You can see for the MPLS layer 3 VPN, we have the, okay, I will draw it here. We have one label is the VPN label. And if you said, oh, we still have another label, because for the MPLS layer 3 VPN, we have the tunnel label. In fact, they are the same length, just not one big, one small. Just I draw the square, not accurate. So one is the tunnel label. So VPN label or tunnel label. And if, for example, you are using MPLS TE, MPLS traffic engineering, if for the fast reroute, sometimes you have the third label. So you will have the maybe some fast reroute, and I just mentioned that here, fast reroute, you will have two layers of labels for the VPN parts, and also for the inter-AS VPN, and also maybe 3 layers of labels that will be used. So maybe multiple layers of labels will be used in the case. So this is one advantage for MPLS. We can put multiple layers of labels to represent the information. But the router will read from the outer label, from the outside one to in, and check this one and do some operation. Always check the outside one, do some operation. And so for the routers, how can they know which one is the last label? And then we will use the S bit. So S will be 1 if for the last label. So here this label is the last one, and then inside is the layer 3 packet. S is 1. And in the front, how many labels? And then all the S will be 0. Okay, so here VPN label S will be 1, and here S is 0, and here S is also 0. So 0, 0, 1. You see, only for the last one, this is the bottom of stack. So S is 1. So this is for the label stacking. And for the LSP setup overview, so LSP, the label switching path, well, as I said, the stable switching path is the table of the labels. So who will allocate the labels? They are allocating the labels, these protocols. They are allocating labels. And the labels will be allocated from the downstream to upstream. So when we talk about the labels, we will talk about the upstream and downstream. What is upstream? What is downstream? The traffic is going from upstream to downstream. What does this mean? That means I send a packet. The packet is going from source to destination. So source, you can imagine, you can consider source is the upstream, destination is the downstream. Of course, anyone can be the source. Anyone also can be the destination. That is just based on your traffic. Based on this traffic, who will be the downstream, who will be the upstream. And so the traffic is going from source to the destination. And so for the label will be allocated, the LSP will be allocated from the downstream to upstream. So from source to destination, you need to use labels. And where is the label from? The label is allocating from downstream to upstream. So R4 will give a label to R3, allocate a label and send it like this. And R3 will allocate a label to R2, 200. And R2 will allocate a label to R1, label 100. And there are also some sequence, some requirements how to allocate labels, but here I only show you the direction is from downstream to upstream. So this is the path how the labels have been allocated. And then after the routers, they have allocated the labels by using these protocols, and then we can form the LSP, label switching path. So we will know, oh, we can use the label 100 to send it to R2, R2 use the 200 send to R3. This is the LSP. So from here, I just want to emphasize the upstream and downstream. The labels are allocated from downstream to upstream. You know, the control plane and the forwarding plane, they are reversed, the different directions. So the control plane are allocating labels from downstream to upstream. Okay, this is how the direction we set up the LSP. And then how to forward the information. And for the set up the LSP, different protocols, some parameters will be different. But we will not go to a detail for that one. And here we'll talk about the forwarding. For MPLS forwarding, there are some parameters, some words, concept we need to introduce before we go to talk about that one. Because here it's quite different from IP. We will use the labels. First is FEC. And when you talk about MPLS, you will see the forwarding equivalence class. Forwarding equivalence class. You see, the name is a class, a group of the traffic, the packets, they will use the same path. So that means a lot of packets, they are using the same path. They are using the same path. So what are the features for this traffic? Because they are using the same path, what will be the feature? And so when people first designing the MPLS talk about FEC, they are thinking about we will based on some features on the packets, maybe some flow and maybe some other features to identify one flow, one group of the traffic. And slowly, when we are really using that one, normally are based on the destination IP address. So all the packets, they are going to the same destination IP address, and then they will use the same path. So then for some people, if you think it's too hard for you to remember all the abbreviations, LSP, LSR, LER, and all this information, or too many abbreviations, you can map the FEC like the destination IP address. I think that will be easier for you to understand the meaning. That means this is the feature they can be used for a group of the traffic. So forwarding equivalence class. And later we will see the destination IP path. And for the push means that we add one or two or three labels into the packet. So for example, this is a pure IP packet. Yeah, here he asked the PowerPoint. Yes, you can go. I will share the FTP link for you to download the material. And for push, and you will a new label will be added. Maybe one new label, maybe two new labels. So might be you have one packet, that IP packet will send from the customer edge, send to our service provider network, and then we will add two labels. One is the VPN label, one is the tunnel label, and then two layers of labels has been added, and we call this is push. And swap, that means we replace the top label, or we replace to be another label, or top two labels will be replaced to another label, so swap. And the other one is pop, remove the label, remove one label, remove two labels, or remove three labels, pop out. I think this part will be easier. Okay, here we will have a look, the forwarding operations. So for the forwarding operations, first you will see the control plane. So when we start forwarding, that means all the control plane has been set up, and then we can forward the information. So these are the forwarding information base, the forwarding information table. And we have for the router 1, for this prefix, and then the local label is none, and out interface is E1, and the out label is 100. And the operation is push. You see, it already told you which operation you should do. So here, please have a look. Please match the local label with the out label. Local label is generated by router 2, and he will send the local label 100 till he will use the maybe LDP message. Okay, the local label is 100 for him. For router 1, he will use the local label for forwarding information. Okay, so here, can you leave your email if you want the copy of this recorded video? Yeah. Okay, so for the out label, and the out label is 100. You see, the local label is 100. This is generated by router 2 and sent to the router 1. Okay, using LDP, please. This is my label. And router 1, when he sends the traffic, he will attach the 100. He will push 100. Same time, local label 200 is the same as the out label 200 here. Local label is 300, and then out label is 300. So you need to know the downstream give the label to upstream, downstream give the label, downstream give the label. And then when we forward the information, here, when the one IP packet come in, and then he will send it to the next router. He will check, oh, incoming, the destination is 100.111. This one we can use the MPLS for forwarding. And then he will say, oh, out label is 100. Okay, push 100 here. Change it to be the MPLS packet. Send it to the router 2. And the router 2, what will he do? You see, he will see incoming label. So the local label, sometimes we will call this incoming label, and here on Cisco routers call it local label. So local label is in fact, you can also match it to incoming label. The packet come in and the label is 100. So from here, from router 2, we don't need to check the prefix. We only check the label is 100 and the outgoing label is 200. What is the operation? Swap. Swap, that means for this label 100, I will change to 200. Swap. And then send out. And for the R3, we'll do the same operation. 200 incoming if this is 200. So he didn't check the prefix. He didn't check the destination is 100.111. I don't need to check. I just check the label because MPLS header is in the front of the IP header, and he will just check the 200. Incoming is 200, and then out label is 300. Operation is swap. Okay, he will swap. change it to be 300. And router 4 will 300, and then the destination is on router 4 is the loopback address. He will pop out the label. So to the last hop. So this is the forwarding operation if we see like this. But normally on the routers nowadays, by default, they have enabled one function. It's called the PHP, penultimate hop popping. So what is that one? So here for the PHP, and here what we'll do is this is the forwarding part, and for the last router, please keep an eye on the last router, penultimate hop, and here is the last hop, and here for the here is the last hop. And for the last hop, what did he do? He has checked the label in the label forwarding information base. He has checked 300, and then pop out 300. And after he pop out 300, when he sent the information to this loopback address, he's also checked the destination. He checked the 100.111. So the IP lookup has also already been done. That means for this label, whatever value, he just needs to pop out. It's unnecessary to check the label value and did the pop. So people want to simplify that one. What will happen? And do we still need this lookup before the IP lookup? So people nowadays by default enabled the PHP. We call this PHP. So for the penultimate hop, he will pop out. Unnecessary to come to router 4 to pop out. It's unnecessary for router 4 because router 4 he didn't check the value. Any value he just pop out because he is the last hop. And here the router 3 is the penultimate hop, the second last one. Okay, so nowadays the PHP has been enabled by default if you are using MPLS, but you can disable if you want. For some situations, maybe people want to disable because they want to carry the quality of service information. If you pop out from here, maybe some quality QoS information has been popped out. Okay, I will not go to that far. And we just focus on the PHP, which is enabled by default. So here the question, so after the packet leaves router 4, it's no longer an MPLS packet at all. No longer. So it finished the MPLS path. Finish MPLS path. You can imagine maybe it's a loopback address. Maybe this is a PE router, and PE router pop out and go to the CE router, pop out a label. That's true. Then that is an IP packet. And in fact, here if we use the PHP, and from here already an IP packet, you can see here the same thing. Just a review. Okay, push 100. And then if incoming is 100, swap, change it to be 200. And if incoming is 200, what should we do? Implicit none. Out label is implicit none. If you are using Cisco routers, you will see the implicit none a lot of parts, out label. But if you are using Huawei routers, they will use label 3, the value 3. So this is the 3. 3 is here. But what is the operation? The label 3 is not used inside the packet. So what will happen? We just pop out the label. You see, we didn't put a 3 here. No, 3 is not in the packet. And 3 just tell you to pop out, to tell you you are the penultimate hop. And I am the last hop. I will tell the previous one, you are the penultimate hop. You just pop out. And here is the IP packet sent to router 4. Router 4 will send it to a destination. So here for router 4, he will only do the IP lookup. He doesn't need to check the MPLS label forwarding table again. So this is for the PHP. I hope this part is clear, because now it's already enabled on the routers by default, and you can disable if you need, for example, the quality of service requirements. And sorry for this picture, the cloud is too big and change the shape because of the Adobe Connect. And here for the time to live processing. Time to live, we know IP has a time to live, MPLS has time to live. So which should we use, and how can they map into each other? And so here for the IP path, if the TTL is 251, and then for the MPLS domain, if we just use the by default TTL propagation, we use propagation. That means in the MPLS domain, he will continue using the time to live from the IP domain, and then we can use that one. So continue to copy, just copy the 251, decrease 1, and then copy it to the time to live in the MPLS label, and then only decrease the outside. And this is the penultimate hop, and so he will decrease and copy it into IP packet, and then continue. So this is the normal default processing, TTL propagation, and then we can copy the TTL inside. We can copy the TTL, copy the IP TTL into the MPLS TTL. So here, and then we get out of the MPLS domain and just copy the TTL back. And you can also disable the TTL propagation. And so if you want to hide the MPLS network topology, and then you can disable. And so what can we do? So in the MPLS domain, he will start the TTL from the 255. So whatever inside your value, I don't care. I just start from the 255 when you get into MPLS domain. So they will start from 255 to 254, and then just follow 250 and then decrease 1 to be 249. So from here you can see he will, in this case, you can disable the TTL propagation, and then if you want to use someone they want to hide the MPLS network, they don't want them to see how many hops in the MPLS domain. You can't trace route from here. So this is one feature. You can disable the propagation, how they are doing that TTL from IP to MPLS. And for the OAM pin, for the MPLS pin, and then you can enable the MPLS. We have the MPLS echo request pin MPLS. So he will use the MPLS path to finish this pin. And for the LSP trace, and this will only use the LSP. And you see the labels. So here from the Cisco routers, and we can see the labels are listed here. You see the labels, and the EXP is the traffic class. So for the MPLS pin, and we need to guarantee the packets will only use the label switching path. He cannot use the IP routing table. So for this is the way how they are doing the trace route or pin, and just for the packets they need to follow the LSP, and you can use trace route MPLS IPv4. And for Cisco routers, normally if you use normal trace route, you can also see the labels if they are using the MPLS path. And for some vendors, maybe you can't see the labels if you just by using the trace route, maybe not following MPLS, is using IP. So if you really want to check the MPLS part, and you can add the index the MPLS here. So this is the MPLS pin, MPLS trace route. We can test whether the LSP has really set up or not. The last part is a little bit of MTU. So when MPLS has been deployed in your network, and the packet size will be longer than normal one because we added at least 1 or 2 layers of the MPLS labels. So for an IPMTU is, for example, here, if MTU we set the 150, 150, 1500, 1500, 1500, and if this packet set the implicit, if this here implicit none, can you tell me again about implicit none? Okay, we will go back a little bit before we move to the MTU implicit none. Implicit none is here is for the label 3. Label 3, that means for the second last hop. So this is the last hop. Then he will start to use the IP forwarding. And for the second last hop, and he will pop out a label. We just want to tell the second last one to pop out a label, unnecessary to come to the last one. So implicit none is sent by the last hop. The last hop will tell the previous router implicit none. And when the second last one, he has received the information, what will he do? He will pop out a label when he sends the packet to the router 4. Oh, okay. So this is implicit none. Implicit none, the value is number 3. And then come back to the last part, MTU. IPMTU, we know IPMTU is for the maximum transmitter unit, the size. And then if we set a don't fragment, so the packet size is 1500 and then can pass these links. And but if the packet size is larger, for example, we add the 2 labels, the MPLS layer 3 VPN 2 layers of labels, and one label is 4 bytes, and then it will be 1508. The size is like this. If it still says the don't fragment, and then the packet will be dropped from the beginning. MTU is 1500. So for this case, and then what can we do? Maybe you have, for the MTU issue, I think different networks you have your solution, and some of you maybe will change the MTU to be larger, and some people recommend, oh, just change to 1530. This is a common value and will be a safe value, can be used. And another one will be change the TCP MSS. Change the TCP MSS is like this. So here, this part is the TCP MSS, and if you change the payload size to be smaller, and then can make sure the packets all can pass the MTU. And normally, if you change the TCP MSS, and then it will make the change part the effect will be smaller, because if you change MTU, you need to change for the whole path for all the routers. And if you change MSS, and then just from the user end side to change the MSS. So this is the for the MTU issue. And here we have a blog, and to talk about this one, you can refer to this link. So that's all for this session. We talk about some background or history of MPLS and how to use MPLS, and also oh, here one question: the unchanged value leave default MTU 1500, right? Yeah, if you didn't change it, then it's the 1500 normally. And but also, yeah, you need to check with some vendors. The different vendors, especially for layer 2 VPN, some MTU values are different. You can also check that one. Do you need iBGP for MPLS VPN to work? For layer 3 VPN, we will use the MPI BGP to set up the set up the neighbors and to allocate the VPN label and to extend the VPN routes. Yes, for exactly is for your question should be okay. For the I will write it here. For MPLS Layer 3 VPN and for MPLS Layer 2 VPN and for the compiler mode. For these two, you need the BGP. For these two, you need the BGP. Yeah, so this is for the VPN parts. Okay, so that's all for this session, and thank you very much. And if you, here I will share the slides with you.